Hello, my name is Luke Walker. I'm with the developer program at YubiKey, and I'm here with my colleague Greg Domzowski, Senior Software Manager. And we're going to be talking about the YubiKey SDK for desktop. But before we dive into this presentation, I'd like to cover a few housekeeping items. If you have any questions during this webinar, please use the Ask a Question tab located below the player. Your question will be addressed during the Q&A session at the end of the presentation. If you have any technical difficulties, click Support for Viewers at the bottom of the page for troubleshooting help. And finally, please take a moment to rate this webinar at the end of the presentation. We'd like to hear your feedback using the Rate This tab. And a recorded version of this presentation will be available using the same URL shortly following the conclusion, so you can replay or share with your colleagues. So, like I mentioned, we're going to be talking about the YubiKey SDK for desktop, its use cases, and touch on some of the high-level getting started concepts, such as how to interact with YubiKey sessions, threading, and such. You can find the links to the YubiKey SDK for desktop and other resources in the tab below if you'd like to dive deeper into the topics that we discussed today. Also, Greg is going to be giving us a hands-on demo showing us how to integrate the SDK. All right, let's get started. We are seeing that users expect more mobility to access their resources at any time from anywhere while demanding greater security and trust. Enterprises see strong identity authentication as a critical part of their network architectures. And YubiKey supports multiple authentication protocols and is uniquely positioned to help individuals and organizations protect their identities as they make progress on their journey to strong authentication everywhere. In order to do their work, users may have to log into an ecosystem of products and services with various authentication methods. They may have to log in through a VPN, which may require a one-time passcode. They may have to log into web applications, which could offer strong authentication with WebAuthn and FIDO2 or strong second factors such as FIDO U2F. YubiKeys are uniquely positioned because they allow users to easily move between these on-premise services or cloud services, between devices like laptops and mobile phones and desktops with a single key that gives the confidence of hardware-backed multi-factor authentication experience everywhere. So let's get into a little bit about the YubiKey SDK for desktop and how this new SDK gives developers access to the full functionality of the YubiKey for enterprise-wide deployments across various platforms. So the main goal of the SDK are to empower the creation of delightful user experiences. We want developers to be able to customize the user authentication experience to reduce friction and increase security to onboard new employees and customers. The SDK's goal is to accelerate developers to reduce development cycles by offering scenario-based API layer without requiring the developer to dive into the low-level dependencies and commands. And another goal of the SDK is to offer consistency. We want to enable secure and fast employee and customer authentication without breaking that user experience that they're used to across their platforms and devices. YubiKey has an evolving and innovating portfolio of software development kits to offer completeness across various platforms. We have a SDK for iOS, for Android, and for desktop. We also have an SDK for our UBHSM. So if we look at how some of the organizations in the industry are using this SDK, they may want, products or services may want to differentiate themselves by giving their users a consistent experience across various platforms, and they come to YubiKey for guidance. So we have an illustration here of some common customer journeys that we're seeing in the industry. You can see that the columns on the table highlight some verticals, while the rows are the use cases or scenarios. So if we look at the first one, smart card configuration, we're seeing people, organizations needing to onboard and configure smart cards with self-service apps for employees, being able to interact with YubiKeys to install and renew certificates, building detection of a YubiKey into the application to know when a YubiKey has been plugged in or disconnected. Also, you may have a crypto officer who needs to manage the smart card PIN and PUC. So we see this across various verticals, customer verticals. But we also have an NFC tap and go experience. Where we see this happening is with shared devices or workstations, like a warehouse computer or a barcode scanner. Maybe like a retail worker will come and take their YubiKey and tap it to log in and get access to the apps they need to do their work. Doctors, maybe they need to access a medical device quickly. They just maybe then they have their YubiKey on their wrist or in their pocket. They can pull it out real quick and log into that medical device. Also, call centers. There's a lot of shared workstation there. You just want somebody to come up to a computer and be able to do their work and sign in quickly. They can just tap and go using NFC. Also, the oath, like time-based OTP, MFA in your custom apps. We've seen this in healthcare. If you're dealing with prescriptions and you want to have a second factor along with your username and password, we've seen customers using that as well, and as well as maybe you're a bank and you have you want to offer time-based OTP experience in your desktop app. So now I'll hand it over to Greg to dive a little bit deeper into the SDK.
Thanks, Luke. The YubiKey SDK for desktop is a new .NET-based SDK from Yubico. From the outset, we wanted to build not just a set of libraries, but a comprehensive set of documentation and sample code to go along with it. We want to make it as easy as possible for developers to write stronger authentication into their applications and workflows. The SDK was built with modularity in mind. Parts of it can be swapped out for alternate implementations. This can allow for all sorts of interesting and exciting scenarios, some of which we will discuss later in this webinar. .NET has been expanding their support for additional operating systems. It's not just for Windows anymore. We are pleased to share that our SDK will support both macOS and Windows out of the gate, with the possibility of additional platform support in the future based on your feedback and interest. The YubiKey isn't just a USB device. Certain keys support near-field communication, or NFC, as well. NFC enables many compelling scenarios, such as tap and go, allowing for fast authentication without the fuss of plugging in a USB device to a computer. Everything that you can do over USB, you can do over NFC. Lastly, if you've worked with our mobile SDKs before, we hope that you'll feel at home. While there are some differences based on the platform and the above design principles, we tried to keep the concepts as familiar as possible. So let's do a quick refresh on some concepts. The YubiKey comes in several form factors, but most of them boil down to a USB device that may or may not have NFC or a Lightning port in the case of the 5CI. Since this SDK only supports macOS and Windows at this time, we will focus on USB and NFC. Even though the YubiKey is a single USB key, your computer will actually see up to 3 different devices depending on how yours is configured. There's a HID keyboard, which is exclusively used by the Yubico OTP application. There is a HID FIDO device, which is used exclusively by the FIDO applications. And then there is a smart card reader with a smart card attached that provides access to all of the other applications. NFC, on the other hand, can talk with all of the applications on the YubiKey. The reader provides both communication and power to the key. Programmatically speaking, NFC behaves very similar to a smart card reader. I keep referring to applications on a YubiKey, but what do I mean by this? As you probably already know, the YubiKey is a multi-protocol device. That is, it supports a wide feature set across different scenarios. When I say application, I'm referring to one of the implemented protocols or collections of features running on the YubiKey. There are two OTP applications. The OTP app, labeled as touch-triggered OTP in this diagram, and the Oath application, which provides the user with time-based and event-based standard OTP. Next, there are two different smart card implementations: OpenPGP, an open standard based on a decentralized web of trust, and PIV, a more centralized certificate-based standard. PIV is typically the application used when people refer to the YubiKey as a smart card. Then we have the FIDO protocols. Use these with WebAuthn for strong authentication for your online services. Lastly, there's the management application, which is not shown here. The management application is used for getting and setting global properties of a YubiKey. Now let's learn more about the SDK. The SDK is actually comprised of three modules: the YubiKey library and two support libraries. The first of these support libraries, .NET Polyfills, is not meant to be used for direct consumption. Since the SDK targets .NET Standard 2.0, we needed to fill in some library gaps to allow us to use most of C# 8's new features. We also wanted a place to backport important features from .NET 5 and 6 for our own internal use. Please note that this library is subject to change, and we are not making any attempt to keep the interface stable. If you would like to take advantage of the newer features of .NET, we advise you to simply target .NET 5 or 6 directly in your application. Moving up the stack, we have the core library. This is where all of the platform abstraction logic is located, including the USB device implementation. Most people will not need to consume any of the core APIs directly. However, there are some useful utilities, such as helper classes for formatting buffers, and reading and writing tag length value or TLV structures that might be helpful in more advanced scenarios. Yubico.YubiKey is the assembly you will want to use. There are three major pieces contained within. First is the YubiKey device object. This class has static methods for finding and enumerating YubiKeys, returning objects with properties and methods for interacting with said key. The YubiKey device is the starting point for the SDK. You can use it to find things like the serial number, getting and setting enabled applications, and more. You will also use it to establish sessions to the various applications on the key. Sessions are active connections to the YubiKey, used for interacting with a particular application on a high level. Look for the OTP session, Oath session, and PIV session classes for interacting with those sets of features. We will be taking a deeper look at the PIV session class in the later demos. All of this is built on top of the command APIs. These are a collection of command and response classes. They wrap all of the encoding and decoding logic necessary to communicate at the lowest levels with the YubiKey. They represent the APDUs in smart card parlance. These APIs are available for anyone to use. They are more verbose, but they also offer the most flexibility. Most developers will want to stick with the session APIs. However, as you will see in a later demo, there is a way to seamlessly transition from one to the other. Now, let's dive into the concepts that you will need to be aware of to be successful using the SDK. First, let's discover how to install the SDK. To get started, let's create a new project in Visual Studio. For simplicity's sake, I will be creating a console-based application so that we can focus on the SDK rather than the UI. I'll give the project a name and select .NET 5 as the target framework. Note that the SDK targets any framework that implements .NET Standard 2.0 or higher. This includes .NET Framework 4.7 and 4.8. To download and install the SDK, we will be using the NuGet Package Manager. Right-click on your project and select Manage NuGet Packages. Go to Browse and search for yubico.yubikey. Please note that during the beta period, you will need to make sure that the Include Pre-Release checkbox is checked. When you find the package, click Install. Visual Studio will notify you of our package's dependencies, of which there are a few. Next, read and accept the license agreements attached to the libraries. And there you have it. You are ready to start building with the YubiKey. Now let's learn how to find YubiKeys. The very first thing you will likely want to do is to find the YubiKey you wish to work with. This can be done in a few ways, but the simplest would be to find all YubiKeys connected to the computer. First, make sure you are using the yubico.yubikey namespace. Next, call the findAll static method on the YubiKey device class. We'll iterate over the collection that is returned and print out basic information for each device we find. When we run the program, you'll notice that multiple YubiKeys were found. You should expect to handle this in your application. If you know how your users will be connecting their YubiKeys to their device, you can do a filtered enumeration to find devices by a particular transport. For example, if you only want to return YubiKeys connected via NFC, you can do that. Instead of calling the findAll method, call the findByTransport method and pass in the transport you want to use. Here, we will only return keys found over NFC. As you saw in this demo, the SDK can detect multiple YubiKeys plugged into the system at one time, whether that be over USB or NFC or both. You should expect to handle this in your application, even if it's to display an error when more than one YubiKey is detected. You can filter enumeration based on a particular physical transport. If you know that your application will only ever interact with a YubiKey over a particular transport, it is suggested that you filter. This will avoid enumerating the other device types, and at least in theory, could offer a slight performance boost. If you know the serial number of the key that you wish to interact with, there is a convenience method for looking up a single key. Lastly, a YubiKey over USB is actually a composite device with three transports: a HID keyboard, a HID FIDO device, and a smart card reader with a smart card attached. When calling findAll, the SDK will do its best to match the three device transports together into a single logical YubiKey device object. This is only possible if the YubiKey has the serial number visible. If the serial number is not visible, the SDK will not be able to match devices and will instead show three different YubiKey device objects. This might be another reason for you to use the findByTransport method in the case where you know how you want to interact with the YubiKey. Now, let's take a look at the YubiKey device object itself. You can see that there are quite a few properties and methods here. These are properties that are global to the YubiKey's configuration. In particular, we see the properties that denote which applications are enabled on the YubiKey. Let's write some code that will disable everything except for the Oath and PIV applications. Let's also print out the property after the operation and run the program. Success! Well, kind of. You'll notice that the before and after are the same and does not reflect what we set. This is because the YubiKey device object represents a snapshot of the YubiKey, not a live copy. In order to get the latest state, you will need to re-enumerate the YubiKey. Let's do that real quick. Since the key is set to auth and piv, let's set it back to all. Now when we run the program, you'll see that the output matches our expectations. Now let's interact with an application on the YubiKey. Each application of the YubiKey has its own namespace. In this version of the SDK, only OTP, auth, and piv are supported. Next, in order to interact with a particular application, we need to create a session. This session establishes an active connection to the YubiKey. It's a disposable object, so let's encase this in a using statement so that we know the resources will be cleaned up after we're done. Piv is based around public-private key cryptography. Let's begin by trying to generate a public-private key pair. Let's build and run the program. Oh no, we hit an exception. Well, that's okay. I was expecting this one. Generating a key requires we authenticate using the management key. But we didn't provide the SDK with any means for collecting credentials. In our next demo, we will look at how we can do this using the key collector delegate. But first, a quick recap. Session classes are what is used to interact with the applications on a YubiKey. In the first version of the SDK, there will be support for OTP, auth, and piv. The session classes are located in their respective namespaces. Simply new up a session, passing the YubiKey device instance you wish to connect to. Management operations, such as editing the global configuration of a YubiKey, is done on the YubiKey device object itself. A session does represent a connection. You are responsible for disposing these objects. On a similar note, the YubiKey is a single-threaded device. Like many other .NET-based SDKs, we do not put any locks or guards in place to ensure a session is called from a single thread. This is up to you, the application developer, to make sure you are only talking to a single key on a single thread. Talking to different keys in parallel is something that is supported, should you choose to do so. Now let's continue on to learn about collecting credentials. The YubiKey has many types of credentials: user pins, admin pins, reset codes, management keys, etc. To provide a uniform means of collecting these credentials, we've introduced the concept of a key collector delegate. This is a method that acts as a dispatch routine for handling all types of credential gathering. It takes in a single parameter with all the request data and returns a Boolean to indicate whether the acquisition of the credential was successful or not. Now that we have stubbed out the collector, let's assign it to the key collector property on the session object before we forget. With that out of the way, let's implement the collector. Since we are generating a key in piv, I know that this requires the management key to be authenticated. If you have any doubt whether a particular method requires authentication, or what method of authentication that it requires, please refer to that method's documentation. Let's switch on the type of the request. And let's implement the piv management key. Here, I'm going to add a basic prompt asking for the management key and read this in as a string. I need to convert this string to a binary representation. I'm going to assume that the string is a hexadecimal value. I'm going to use a utility class from the core library to help with the conversion. Take this value and call the submit value function on the entry data structure. Return true to indicate that credential was gathered successfully. To finish this demo off, let's print out the public key portion to the console. Remember that the private key is generated and stored on the YubiKey and never leaves the device. Let's run the program. You can see that I have been prompted to enter a management key as expected. It's still set to the default, so let's enter that in. Success! The key has been generated, and you can see the public key portion here on the screen. Implement a key collector to gather credentials. Once assigned to a session object, the SDK will automatically call it whenever the YubiKey requests an authentication to occur. The delegate assignment is only valid for the lifetime of the session object. Now let's move on to a more advanced topic. As stated earlier in the presentation, we built this SDK with modularity in mind. This includes the ability to swap out the default crypto implementation with your own. By default, the SDK uses the cryptography provided by the .NET base class libraries. These are the classes that live within system.security.cryptography. Keep in mind, though, that this is only for swapping out any crypto functions that the SDK uses directly. For many commands, the cryptographic operations are happening on the YubiKey itself, and those cannot be modified. Still, if you feel more comfortable using an alternate crypto implementation, whether that be the popular Bouncy Castle libraries, an OpenSSL implementation, or even a hardware accelerator, you can do that. This is because the SDK uses a centralized cryptography providers class that contains delegates for creating the various crypto objects we use. Simply override one of these delegates, and the SDK will now use that implementation. Suffice to say, if you aren't sure whether your application needs this functionality, the answer is most likely no. To get started, let's use the system.security.cryptography and the yubico.yubikey.cryptography namespaces. Looking at the cryptography providers class, you can see the delegates for all the types of crypto objects the SDK uses. And don't worry, we're only using algorithms such as SHA-1 and DES when standards protocols require it. Sometimes there's just no getting around that. For this demo, let's override the default random number generator. You can see that this property expects a function that takes no parameters and returns a random number generator based type. While your implementation won't be .NET's, we still use the .NET base class library's interface for all of these objects. Some adaptation from your library may be required. To show what such an adapter might look like, I'm going to derive the random number generator class and implement the getBytes method. Here I'm doing something really silly. I'm filling all of the array with zeros. Please don't ever do this. This is meant to act as a stand-in for the call out to your own crypto library's random number generator function. Lastly, we need to implement the creator method. Now we can assign that to the RNG creator delegate on the cryptography providers class. Whenever the SDK needs to generate a random number, it will call the creator method to get an RNG object, and it will use the one that you've provided. Let's take a look at another advanced topic. Sometimes the session APIs don't have the exact functionality you need. You need to interact with the YubiKey in a very specific way. This is where low-level commands can help. Each application namespace has a nested namespace underneath called commands. This is where all of the command and response classes are located. They represent the low-level commands and APDUs that can be sent to and from the YubiKey. In fact, the session APIs are built on top of these classes. But the session APIs are also, in many cases, a subset of what is available in the command classes. For example, I want to read a particular data object from the PIV object store. I know the PIV specification has a command called getData. And here it is, a getData command class. The command's parameters can be set either by constructor or by object property initialization. Either way, all that matters is that the necessary information is there before sending this command to the YubiKey. But how do we do that? Well, we can use the underlying YubiKey connection object that the session is using. This is available via the connection property on the session object. The connection has a method called sendCommand, which I will call. This method will return the correct, strongly typed response class. In this case, a getDataResponse instance. From there, I can call the getData method to return the data payload, if any. In this case, I'm printing out the cardholder's unique identifier, or the CHUID. The low-level commands represent the APDU and command response mappings for all the operations on a YubiKey. This increase in fidelity comes at a cost of a more verbose API, but you'll get full coverage for the OTP, OAuth, and PIV applications. If the YubiKey can do it, you can exercise that functionality through the command classes. You can easily transition from the session APIs to the command classes by using the session's underlying connection property. So where are we and where are we going? Available today, as of the end of June 2021, you can manage the YubiKey's global configuration. You can use OAuth for TOTP and HOTP functionality. You can write PIV smart card applications. And you can interact with the OTP application using the low-level command classes. This all works the same, regardless of whether the YubiKey is used as a USB device or an NFC device. In fact, a majority of the demos today were done over NFC. This is all available on both macOS and Windows. Please note at the time of this recording, the Apple Silicon native builds of .NET 6.0 are still too incomplete to be used, but Rosetta 2 should work just fine. We will be doing a beta refresh sometime early July to finish off the OTP session APIs. Documentation is available today on docs.yubico.com/YESDK. It's still a work in progress, but please know that this is the current focus of the team. We will be updating the docs on a fairly regular basis over the next few months and beyond. Sample code will also be posted soon. That is, full sample projects will be made available to supplement the numerous code snippets found in our documentation. As mentioned in the beginning of this presentation, Linux will not be supported in version 1.0 of the SDK, but we are eager to learn about what distributions you would like us to support so that we can evaluate that for version 1.1. Likewise, let us know if Xamarin Mobile support would be something that would interest you. We already have the excellent YubiKit mobile SDKs for a native build experience, but let us know if you're interested in running .NET everywhere.
Thanks, Greg. So as he mentioned, you can find the SDK on NuGet. Greg talked about where you can find the documentation on docs.yubico.com/YESDK. And if you have a problem or you're looking to get some help or a question answered, we have desktop SDK beta at yubico.com. Send your question or issue there, and we'll be happy to help out. So now let's go to the Q&A session. There was some questions asked during this presentation, and we'll try to answer as many as we can. You with me, Greg?
I am. Hello.
Awesome. All right. The first question was, is there a YubiKey SDK sample code repository available on GitHub or similar?
Yes, so we will be posting the sample code projects developer.yubico.com. There will be a landing page put up probably in the next few days, which will have links to post the documentation.
All right. So hopefully everyone can hear you. It's a little grainy for me, but yeah, he mentioned that code samples will be posted to the YubiKey developer site here in a few days.
Yeah, I apologize for that. The break talk changed microphone on me. Is this better?
All right. Well, while you're working on that, I'll ask the next question.
Okay.
Regarding the configuration of the supported interfaces, OTP, OAuth, etc., is the configuration key used to secure this supported by the SDK?
Yes, the configuration key is supported.
All right. Let's keep going. Can I use the SDK to automatically perform an action if a YubiKey is inserted or removed or brought near via NFC?
Yes and no. So we don't at this time provide any events or callbacks other than what you saw when the YubiKey requests that a credential be entered or a touch is requested. So entering a YubiKey system right now, either you will need to pull or you can drop down and use the core APIs to listen to USB device arrival. We do plan to improve this experience in the next version. If there is enough feedback that no, like don't wait for version 1.1, we can consider this for 1.1.
All right, so you can poll and look for improvements in the future. Got it. Next question, can the SDK be used to program keys like the YubiKey manager?
Yes. YubiKey manager can do things that act globally on the YubiKey, such as turning on and off applications, setting things like the CCIP auto eject timeout, setting the configuration key that was asked in the previous question. So yes, the SDK can do all of this. Likewise, anything that is supported by the YK line for OTP, OAuth, and PIV is supported under the SDK as well.
All right, thank you. Next question. Does this SDK work on all versions of Windows and macOS? And I think you kind of hinted at this in the presentation, but yeah.
Yes. Well, not all versions. It works for all currently supported versions of Windows 10. We do not support Windows 7 anymore, as that is no longer supported by Microsoft themselves. And for macOS, we support Catalina and Big Sur.
right. Next question. Is the SDK free, or do I have to register or acquire a license?
Yes, the SDK is free. You can download it on NuGet. Right now, it's released under YubiKey's tools and libraries agreement. But I am excited to share that later this summer we will be releasing it as open source under the Apache 2 license.
That's great news. Another question. Will the FIDO U2F or FIDO2 protocols be supported by the SDK?
Not in this version. We chose to prioritize applications that we know our customers are need help with interacting with directly. The nice thing about FIDO and WebAuthn and all of those is that each operating system and platform tend to have APIs to interact with FIDO authenticators built in. So here, we will be adding support in most likely in version 1.1 to support all of the features that we can do. But in this first version, we felt comfortable telling people, well, if you want to build a FIDO or WebAuthn authentication experience, you're most likely going to want to use your operating systems built in.
All right. Thank you, Greg, and everyone who attended today's presentation. Please go to NuGet, download, install, try out the SDK. Give us your feedback if you have questions or get stuck via the email desktopsdkbeta@yubico.com. And please remember to take a minute to rate this and enjoy the rest of your day.
Thank you so much.